With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question it is given that the circuit in the circuit switch S1 and S2 has been closed for 1 second and S2 remains open. Now initially this and these are closed and this is open. Now after 1 second what is done? S2 is closed and S1 and S3 are open. So now this and this are open and this is closed. Okay, so basically it would be essentially an what RL circuit. Okay, sorry, CL or LC circuit. Now after that instant, the charge on the upper plate of the capacitor as a function of time, taking the instant of switching on S2 and switching off all the time switches to be t equals to 0. That means after we have just switch close this switch, then we will be considering that time is equals to 0. From there onward, we get the equation of charge as x into 10 raised to the power minus 2 cos t plus pi by 4. We need to find what is the value of x. Okay, so this is the situation. Now first of all, if we just see, initially we have closed this one and we have closed this one. So what will happen up till t equals to 1 second? So basically here we can say that this is our capacitor. Here this would be our capacitor, this would be inductor. So the capacitor would be initially charged. Okay, so up to a potential of what? Up to a potential of 1 volt. Now how is the charge developed on the capacitor as a function of time? So initially it would be an RC circuit. So we can say that this is our RC circuit. For the case of RC circuit, what is our charge given? Charge Q is equals to Q naught, which is the maximum charge, 1 minus e to the power minus t by tau, where tau is what? Tau is the time constant, which is equals to RC. Now in this part, what is our resistance is 1, capacitance is 1, so tau would be equals to 1. Now what would be the value of the maximum charge? Q naught. So Q naught would be basically Q naught. This would be equals to basically after a long time what will happen? So there won't be any current which would be flowing in the circuit. So after a long time, this whole 1 volt would be across our this capacitor. So we say that the maximum charge would be equals to C into V. So 1 into 1, this is equals to 1 coulomb. So what is the value of Q as a function of time? For the first part, Q equals to 1 minus e to the power minus t. Okay, now at just 1 second, at t equals to 1 second, at t equals to 1 second, what is the value of charge? So Q value would be equals to 1 minus 1 divided by E. This is the value of the charge. Okay, now this is for what we have done. This is for the this RC circuit. Now for LR circuit, if we do the same thing, so here we will be getting the value of the current. So I is written as I max. So this is for LR circuit. Okay, I equals to I naught, or the maximum value of the this current, 1 minus e to the power minus t divided by tau. Okay, where tau is the time constant. In this case, for an LR circuit, it is given as to be L by R. Now inductance is 1, resistance is 1, so it would be equals to 1. Okay, so the unit is seconds. Now what would be the value of the maximum current? So for the case of maximum current, I value would be equals to, what is the value of the potential difference? So potential difference is 1, resistance is 1, so the maximum current would be equals to V divided by R. This would be equals to 1 by 1, that means 1. So this is the maximum value of the current. So I as a function of time could be written as I equals to, so we are solving this for the first part of the problem. I naught value is 1, so we can just write it 1 minus e to the power minus t. Now just at t equals to 1 second, what is the value of the current? So t equals to 1 second, I value would be equals to 1 minus 1 divided by e. Now from here onward, what we have done, now we have closed this switch. Now we have closed this switch and opened this. So this is opened and this is opened. Okay, so what will happen? So it would be basically an LC circuit. Okay, so it would be just an LC circuit. So initially this would be having a current and this would be having charge. So initially it would be having energy, So after some period of time, what will happen? Capacitor would be discharged and total energy would be given to the inductor. Now after certain period of time, some more amount of time, the total energy would be given to the capacitor. Okay, and capacitor would be fully charged. So we can say that the total energy for this LR circuit, this LC circuit, we can say that the energy would remain conserved. So E total would be equals to, when the capacitor is fully charged, so it would be equals to Q max square divided by 2C. And when inductor this capacitor would be totally discharged, so the total amount of current would be given to the inductor. So I max square divided by 2. Now what is the total energy? So we can say that it is the energy of the capacitor plus energy of the inductor. Okay, EC plus EL. EC plus EL. Okay, this would be equals to what? This would be equals to Q max square divided by 2c. Now from this expression we can get the value of q max. So this is what is the maximum charge which is given here. So q is equals to q max cos t plus pi by 4. If we get to know what is the value of q max, then from the comparison we can get what is the value of x. Now we just write what is the initial energy of the capacitor. So capacitor energy, what is the initial charge? It is 1 minus 1 by e. So 1 minus 1 divided by e square divided by 2 into capacitance. Capacitance is 1. What is the initial energy of the inductor? It would be equals to L, and then this current, which is equals to 1 minus 1 divided by e square divided by 2. This would be equals to q max e square divided by 2c. Okay. Now from this expression we can get the value of q max would then turn out to be root 2 times 1 minus 1 divided by e. So this is the maximum value of the charge. Now if we wanted to just get the this expression for the charge, we know that for an LC circuit, so charge could be given as to be q max cos omega t plus phi. Okay. Now we know that at t equals to at t equals to 1 second, or we can say that for t equals to 1 second would be for the initial case. Now it is given in the question that we will be considering t equals to 0 when we have just closed the switch this part. That means t equals to 1 for the initial part would be t equals to 0 for the second part. So here we can say that our t equals to 0 at t equals to 0. What is the value of the charge? We have just calculated 1 minus here we have calculated 1 minus 1 divided by e. So t equals to 1 was for the initial part. Now we are considering t equals to 1 as to be equals to t equals to 0. So we say that the charge value is 1 minus 1 divided by e. Okay, and if we just put the value of charge here, then the q max value, we know that root 2 1 minus 1 divided by e, cos we put the value of time to be 0, so this term would be 0, so it would be just equals to phi. So from this expression 1 minus 1 by e term would be cancelled. It would be just cos phi equals to 1 by root 2. That means phi would be equals to pi by 4. Now if we put all the values into this expression, then q would be equals to q max, which is root 2 1 minus 1 divided by e cos of omega t plus pi by 4. So if we solve this, then this part would turn out to be q equals to, it would turn out to be 89 into 10 raised to the power minus 2 cos omega t plus pi by 4. And what is given? Charge is given as to be x into 10 raised to the power minus 2 cos of omega t plus pi by 4. Now if we just do a simple comparison, we get the value of x as to be equals to what? X would be equals to 89. So x would be equals to 89. This is the final answer. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.